All right, hey, so this is a video of me going through the problems on page 10, just in case there was anything that you were unsure of, if you wanted to review scientific notation. So for the first problem that we have over here, when you're multiplying 3.098 times 10 to the fourth, and then you multiply that same number times 10 cubed, obviously multiplying it by 10,000 is going to give us a bigger answer than multiplying it by just 1,000. So I have the numbers in red, but you could also just compare that the 10 to the fourth is bigger than 10 cubed, and so that one would be greater. Same logic over here. The exponent of 5 is bigger than the exponent of 2. So multiplying something by 100,000 is going to be larger than multiplying it by 100. Again, I have the numbers here in red if you need to see it, but the shortcut with the exponents will work. Now over here, when I move the decimal back twice, this time it's a negative, so I'm going to move it back twice. And this time it's negative, so I'm going to move it back 3 times. I've got the decimals in blue so that we can compare. And right there, the underlined red number in the 100 spot, we can compare the 5 to the 0 and see that this one's bigger. Our shortcut with the exponents will work because negative 2 is closer to 0 than negative 3, so that one's bigger. So the alligator symbol is eating this number. For this multiple choice problem, 90,001 in scientific notation, this exponent right here says we're going to move this 4 times. And when I move it 4 times, I'm at 90,001. So this is times 10,000, and 9 something times 10,000 should be 90,000 something. Now for the next problem, we just want to practice going from scientific notation back to standard. If you take this 1.03 and you move the decimal back once, twice, and now fill in with a 0 point, there's the 0.0, and then that's the 103 right there. So this one was G. Now for the least to greatest section, I have the answers in red when we convert them. So for example, this one, the 6.98 times 10 to the negative 3, when you move that decimal back 3 times, 1, 2, 3, it's going to be this answer. When you take this negative exponent and you move it back twice, the 3.2 back twice, it's 0.032. Now here with the positive exponent, I got a positive 4, a positive 7, a positive 6. Friendly reminder that the decimal is going to move to the right. So this one, I move the decimal to the right 4 times, and I get 40,160. Here, if I move it to the right 6 times, I'm in the 9 millions, and for the largest number, it'll be 83 million. But I wanted to point out here, folks, by highlighting, that if you just take the negatives from least to greatest, and then 4, 6, 7, notice in my answer, those are in order from least to greatest. So we do have a shortcut here, well, that'll work. Now for the next one, it's very easy to spot for the shortcut that the 4th power is the smallest one. So 2.14 times 10 to the 4th is going to be the smallest answer. But now in yellow, take a look, we have 2 of them that would tie. So if you want to go after which one would be smaller, all you've got to do now is take a look at this number compared to this number. 8 something times 100,000 is going to be 803,000. This is going to be 940,000. So this one would be the next one. Then this would be in the middle. Now same thing when our 8s tie. This is the next smallest. And then 8.25 times 10 to the 8th one, that one would be the biggest number. Okay? For determining the exponent, if we have a 3.1 and we want it to be 301,000, we need to move it 1, 2, 3, 4, 5 times, and those would fill in with zeros. So this one was actually C. Some of you fell for it and you picked A because you counted the 3 zeros. And y'all, if that only moved 3 times, it'd be 3,010. Now for this exponent, we want this again to become a number between 1 and 10. So to make it happen, we need to move it once, twice, 3 times. So it had to move 3 times, and to check our answer that it's a negative 3, because we got a teeny tiny decimal, let's take 6.83. If it was 6.83 times 10 to the negative 3, this is what we're checking for now. We're going to take that decimal and move it back 1, 2, 3. And when we fill in with our zeros, what do you know? We do get the correct decimal. For number 1 down here, the average house in Springfield costs $450,000. So there's the $450,000 written out. So to make that a number between 1 and 10, you'd move the decimal here, 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 then here, and now it's a 4.5. And we moved it once, twice, 3, 4, 5 times to make that happen. So this answer was C. And that concludes the video on page 10. Thank you.